Yeah. Good evening, everyone. Okay. Yeah, that is perfect. Okay, let us start this session. Fine. See, many of you guys had confused with the question that you had posted in the group, right? So let me take that question actually. What is the answer for that question? See, what I had been told you according to the basics, right? So first, let me take that question first. Take that question that, yeah, ma'am, I think someone posted in the group. I don't know her exact name. Fine. Anyway, let me read the question. What was that function given, right? In the function given it is, see, the function is f of a comma b comma c comma d, right, can be considered as max terms. It clearly given as max terms 0 comma 1 comma 3 comma 4 comma 5 comma 7 comma 9 comma 11 comma 12 comma 13 comma 14 comma 15. That is what they given as max terms. Now just to read that question, is a max term representation of a boolean function of abcd, and A is the MSB and D is the LSB, of course. Now the question just make understood that statement, right? The equivalent question is the equivalent, right? Question is the equivalent minimized representation, equivalent minimized representation, right? So equivalent minimized representation, that is the question. See, the key is beginning of this word equivalent minimized representation, right? So let's try and bring the answer for this question. See, I told you now, it's almost what POS to SOP conversion, right? So because the thing is, what they are asking you, you are requested to find out the equivalent minimized expression. First thing you all have to understand, right? One of you, right, that is made one more that is conversation, right? I was not satisfied with that conversation also. See, the thing is, it's very simple, right? It's very simple. There are no point to discuss here. The thing is, equivalent minimized in the sense, given it is max term, its equivalent person is your min term, right? Its equivalent person is min term. We all know the equivalent person of the max term is known as min term, right? So this max term should be equal to sum of min term values. How many min terms variables are there? Let's see. 0, 1, 2 is missing here. 3, 4, 5, 6 is missing, 7, 8 is missing, 9, 10 is missing, 11, 12, 13, 14, 15. Rest of all variables were available in max terms, right? So these two guys are always giving same information for us. Do you all agree with me? Yes, that is correct, right? So you are requested to find out the equivalent minimized expression in the sense, this statement clearly denotes that you are supposed to write your answer in minimized form, that is in sum of product form, that is in SOP form. Clear? So equivalent minimized in the sense SOP, first statement, right? So the next statement, why are you thinking like, sir, option A I am getting, option C I am getting? That blob stories does not require. What I had been told you, equivalent minimized in the sense, given it is max term, its equivalent is min term. Directly enter into that and write down the answer. Don't think whether it is, you don't need to consider this max term, you don't need to write any boolean expression, you don't need to take complement. That blob stories does not require. Whichever the things that I taught, just to follow that procedure, don't follow any other kind of methods. Definitely it will confuse you, because there will be some another method. K-map la irundha nama enna panikalam appadina SOP POS direct ah நம்மால relate பண்ணி கொண்டு வர முடியும். But that method will often confuse you if you are going with that logic. That statement does not require. If max term will be given, directly put these max terms into the K-map. You know how to write the boolean expression for max terms. I taught. Similarly, if min terms will be given, directly put the min terms into the K-map. So write the boolean expression for min term. That conversion, don't follow that procedure. Even I too, right, I usually thought that procedure for the people, but later only I understood that method is often letting them to confuse when they are facing new questions. So don't follow any methods, don't follow any procedures given in any books, right? So just to follow, max term means max term table, min term is min term table. If min term will be given, if you are requested to write down the expressions for max term, we know the relation. Now in this statement they clearly said, sir, given it is max term, write down its equivalent minimized Boolean expression. In the sense equivalent in the word automatically you should think about min term only. Why the hell are you thinking about max term? There is no point, right? So let me write the answer directly. See, for 2, since we are considering 4 variable, now how will you write? For 2 we can consider 0 0 1 0, that is for 2, and for 6 we can consider 0 1 1 0. Yes or no? Exactly. For 8 we are requested to consider 1 0 0, and for 10 we are requested to consider 1 0 1 0. I hope I am correct. Clear? Let's continue with this. Our journey is 2. For 2, it's equivalent to minimized expression. How will you write? Directly. See, zeros are not acceptable in SOP form. So the answer is going to be A bar, B bar, C bar, D bar. Right? No, that is 2. Sorry, I did not notice. 2 in the sense 1 is acceptable but 0 is not acceptable. Plus, second variable 0 1 1 0. What is your answer? A bar, B, C, D bar. Plus, and the third term is going to be A, B bar, C bar, D bar. Plus, fourth term is going to be A, B bar, C, D bar. Clear? That's all. That is going to be your min term expression. You no need to be panic about this statement that I am giving here. Why? Because the question is equivalent minimized expression only you are requested to find. Clear? That's all. See, if you want to reduce this function further, you can put it, you can, either you can further you can minimize, right? Further you can minimize this expression, right? Wait a minute, I have to get back to the so am I correct? Is can we reduce this function further? So first of all, in the option A is not answer, not our answer. Option B is also not our answer. Option C, A bar, C, D bar. A bar, C, D bar. A bar, C, D bar. See, A bar, C, D bar. From these two expressions, you can take A bar, C, D bar outside, such that B plus B bar will become 1. Clear? Plus rest of 2 terms. Let's consider A, B bar, C bar, D bar, plus A, B bar, C, D bar. So the correct answer is option C. That's all. Don't think rest of things. You don't need to think whether the option A is correct or not, right? You don't need to be wonder about those things at all, right? I'm not requesting you to do those things. Just to consider equivalent to minimized expression. That is what I'm writing. That is going to be the answer. Just to fix it, right? So that is option C is the correct answer. Don't think about rest of things. Okay. I hope things are clear to you all. Okay. Anyway, let me getting back to the class. I'm out of the class now. Yeah. Let's see. Okay. Fine. So the thing is strictly follow, right? I told you 2 conversions. Now you know how to write the equivalent expression from SOP to POS and POS to SOP. And you also know how to write the standard expression for max term, min term separately. Don't mingle them while solving the problem. That's my sincere request. Definitely, there are some other procedures. I'm repeating, there are some other procedures, but don't follow it. Don't follow it, right? These methods that I taught, that is more than sufficient. You can clearly, without any doubts, you can proceed, right? Without any hesitations at all. Definitely you'll get the answer, trust me. Okay, fine. Okay, let's continue. Next, what we are going to do, actually we are discussing about what we are designing the circuits. They are called combinational circuits, that is memoryless circuits, right? So we are designing memoryless circuits in order to do arithmetic operations, right? So yesterday we have done addition. Now our next target, we have to perform subtraction, right? So we have to perform subtraction, right? So we are going to design subtractor. So in order to design, that is once again, while designing subtractor, there are 2 types of subtractor that we can design. One is half subtractor and second we are going to design full subtractor, right? Okay, I hope you all have seen. Anyway, till now if you have not seen, at least today night, just to see what is the drawback of half subtractor and half adder. I told you already, right? Fine. If any one of you find that answer, please post it in the comment section, right? So let me know that one. Fine. Let's start our journey with the second type of arithmetic operation, is simply called what I can say subtraction, right? So for that, I'm going to design the first person is called half subtractor. Let's go ahead with the half subtractor, right? So let us start our journey with the half subtractor. With the half subtractor, what we are going to do? Once again, we are going to consider 2 Boolean variables A, B, and they have 4 possibilities: 0, 0, 0, 1, 1 0 1 1, and in the output side we are going to get two things. First we are going to find the difference between these two people, that is called difference, right? The difference in the sense subtraction, and with this we are also going to consider one more person, that is called borrow, right? Yeah, let's start our journey. Let's try and bring out the answer. You please do it by yourself, right? Because we know how to do difference, that is how to find the difference of the variables. Already I taught these things, right? So let's start our journey with this. Now the output of the variables are going to be 0 minus 0 will give you 0. There is no need to buy any borrow. Now 0 minus 1, you cannot subtract 1 from 0. In order to subtract 1 from 0, I will have to buy, I have to lend, that is borrow from outside, such that this 1, that is 0, add up with the 1, so it is going to be 10 now. So 10 minus 1 is going to be 1, whereas I bought 1 borrow, so I have to keep that 1 here. Now 0 can be subtracted from 1, such that 1 minus 0 is going to be 1 only. There is no need of borrow, right? 1 minus 1 automatically 0, there is no need of borrow. Let's write the output expression for this. So the difference, right? So directly we can write without there is no need of k-map at all. So we got two minimized, that is I would like to write the expression in SOP form only, in SOP form, and I'm just considering min terms. Min terms in the sense output must be equal to 1. So here there are two terms, its outputs are going to be equal to 1. Its correspondent terms are being considered as a bar into b plus, and for the second term we are going to consider a into b bar. Now I understood this is known as what? This is my XOR logic only. This is our XOR logic gate, right? Exactly. Now I would like to find out the borrow of the function, right? So borrow in the sense, borrow means what we have to do? Borrow means we had only one. See that this is only one min term. Its correspondent variables are going to be a bar into b. So first step we have to frame the truth table. Second step we have to write the Boolean expression. Step number 3 we have to implement the logic circuit, right? Yes. So let's start our journey with that. Yeah. Fine. Next, what we have to do? Let us design the circuit. First, we are going to get two outputs. One is difference, another one is borrow, right? So in order to derive these two outputs from the input side, first difference ku ungalku enna venum? One XOR gate sufficient in order to produce difference, right? So let us take one XOR gate, right? Just let me consider one XOR gate, and let us produce the output, that is going to be difference, right? So here if I will pass AB as the input, automatically difference output is going to be A XORed with B. Okay, next we should know the value of, now we have to find out the value of borrow. Borrow means what we have to do? If you notice this borrow carefully, so here listen, A bar dot B. Meaning first we have to take complement for A such that I am putting an inverter, right, with A, and then we are considering one AND gate such that what happens now, just to see there, if I pass A through the inverter, it will become A bar. So this is going to be B. So A bar dot B is going to be the borrow. So borrow is going to be what? A bar dot B. Exactly, that is correct, right? Now half subtractor is over. Our next task, we have to design full subtractor. Yeah, so let me rub this one. So let us design full subtractor. So next task, we have to design full subtractor, right? So yeah, full subtractor. What we are going to do in full subtractor, you please do it by yourself if it is possible, right? Because there are no new things, right? Full subtractor in the sense, for example, we are going to consider 3 variables, right? Under 8 combinations: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, and its correspondent outputs are going to be difference and borrow, right? Its correspondent outputs are going to be difference and borrow. Let's write the output values. Shall we start our journey? See, once again, in full subtractor also, at a time you cannot subtract all the variables. You have to select 2 single bits and you can perform the subtraction, and then you can continue the same operation. So that's the drawback, right? So let's continue our journey. 0 minus 0 will be 0. Again 0 minus 0 will be 0 only. There is no borrow. Again 0 minus 0 will be 0 only, but 0 minus 1 it is not possible. So we have to buy, that is we have to borrow. So 10 minus 1 will going to be 1. Again 0 minus 1 is not possible. I have to borrow such that 10 minus 1 will be 1, 1 minus 0 will be 1 only. Now 0 minus 1 is not possible. I have to once again buy 1 such that it will become 10. So 10 minus 1 is going to be 1, 1 minus 1 will going to give you 0. Next 1 minus 0 could be possible. Again 1 minus 0 could be possible. There is no borrow. Again 1 minus 0 could be possible. So 1 minus 1 is going to be 0. There is no borrow. Again 1 minus 1 will be 0. 0 minus 0 will be 0 only. There is no borrow. Again 1 minus 1 will be 0. But 0 minus 1 is not possible. I have to lend 1 outside such that it will become 10. So 10 minus 1 is going to be 1. Clear? So that is how we are getting the outputs for subtractor. Okay. I hope things are clear to you all. Already we learn, right, how to do, or that is how to perform subtraction, right? So anyway, now let me put them into the K-map in order to obtain the resultant expression, right? So anyway, we can write the expression directly, but for your understanding, I'm doing this one, right? So if I'll put it in the K-map, let's see what happened. Once again, we are going to use, we are going to write this function in SOP form only, right? So in SOP form, in the sense, it can be considered as A bar A, it can be considered as B bar C bar. This is going to be B bar C, this is going to be BC, and the last term is going to be BC bar. Let's try and register the variables into the box such that it is going to be 0, 1, right, 1, this is going to be 2, 3, and this is going to be 4, 5, 6, and this is going to be 7. Let's register the variables, right? So 0, 1 is here, and 2 is available, 3 is not available, 4 is available, 5, 6, 7 is available. Rest of are called max terms. See there, can we group them? There is no possibilities, right? So individual grouping only could be possible. Minimum 2 grouping also not possible here. Such that there is no need of K-map. We can directly write the expression for difference. So what you are going to get for this one, I am going to get A, B bar, C bar, plus second for this one, we are going to get A bar, B bar, C. For the third one, for this one, did I wrote this one? Yeah, I wrote this one, I have to write this one. A, B, C, plus this is going to be what? A bar, B, C bar. Did you notice one thing? This is known as what? This output expression is known as A XR B XR with the C only. There is no changes in the difference. It is same as our adder, full adder, right? Now, borrow is different. So, let's try and bring the answer for borrow. Now, to bring the answer for borrow, let us remove this portion, right? So, because I don't have space. Yeah. So, let's try and bring the answer for borrow. Now what will be our answer for borrow, right? So let's write for borrow. Again I have to consider how many variables. Okay, first let's put them into the K-map such that it will be easy for us. If we find any grouping, then we will be happy, otherwise we will write the answer directly, no problem. So let's write. Once again we are going to consider A bar A, and this is going to be B bar C bar, and B bar C, this is going to be BC, this is going to be BC bar. Let's register the variables 0, 1, 2, 3, 4, 5, 6, 7. Okay, is there any grouping? Can you do grouping here? Of course I can do grouping, right? So I understood there are groupings are possible here. We can group these two guys. Of course we can also group these two guys. Of course we can also group these two guys. Okay, now if I will write the answer from here, what I will going to get, that is the borrow answer can be written as what, and it is the simplified version. Let us take the first grouping, that will give us A bar into, here we are getting AC. Now in this grouping we are going to get only BC, and again in this grouping we are going to get A, and the common term between these two guys is B only. Now remember one more thing, actually it is the minimized form of these 4 minterms, right? Actually so this is actually it is equivalent value of 1, this is 2, this is 3, and this is for 7, correct? Yes, it's equivalent value. 1 ku neenga minterm eppadi eluduveenga? 1 can be written as A bar B C bar, correct? And then yeah, actually for 1 we have to consider A bar B bar C, right? 0 0 1 plus, and then for 2 we can written as we can write A bar B C bar, correct? And then for 3 we can write A bar B C, and then for 7 we can write A B C. This is actually its minimized form is this one. Its minimized form is this one. Fine. Now how can we write this expression? If you notice these things carefully, if I'll take A bar outside from the first two expressions, it is become B bar C plus B C bar. That is B X bar with the C. Am I correct? Of course I am correct, right? So just we shall keep these things like this. Similarly, is there any other common term? I think from these two we can take BC outside, right? So if we take BC outside, then it's become A plus A bar, that is become 1, right? So that is going to be the borrow. We can also write like this. See, in order to develop the diagrams, that's all. There are no more things to discuss, right? So, okay, let me keep them in your side. So the borrow is going to be, right? So the borrow is going to be, we can write just A bar into B XORed with C plus BC. That is the output for borrow that I am getting. And this is equal to this one, minimized form, right? Fine. So let me rub this one and let's try and develop the full adder circuit, right? So let's try and bring the full adder circuit, right? Yeah, that, sorry, not full adder, full subtractor, right? So next target is we have to bring full subtractor, right? So let's try and bring the answer for that one. Yeah, what shall we do now? Just all the standard circuit only, right? So let me draw the circuit first. Be patient, right? So first let me to complete the circuit, okay? And then here let me consider a an AND gate. Okay, one inverter should be required for us in order to complete the first half order circuit. Let's try and complete the second one also, right? Second circuit, again we have to design one more half order. Yes, and from here also we have to take same output, and yeah, I took that one also. Second half order also over. Next we have to group these two guys together. It is same as our full order, right? So except the variables changes, right? So here we are going to consider one OR gate, such that here we are going to get borrow and here we are going to get difference, right? So let's see what we are going to get in the output side. So here I'm going to provide variable A, variable B, variable C. Since it is XOR gate na, the output A is going to be XORed with B. Exactly, that is correct. And here it is become A bar, and here it is B, such that output is going to be A bar B. Exactly correct? Yes. And this is going to be C. This C will go here, such that again this XOR gate will produce A XOR B XOR C. That is correct. Now this A XOR B will go here, right? And here we should take, see there, wait a minute. Yeah, now see there, this A XOR B will go here, right? At the same time the C is coming here, right? So where is that C? See there, this C is coming here, such that let's let this C to go here, right? Let us let this one to go here, right? Now what you have to do, if I let this function, right, actually what we have, this AND gate will be here and this will give us this is going to be okay, fine. Let's continue our journey with this. Let's try and bring the answer. That is A XOR of B, and here I am getting C, such that it output is going to be A XOR of B into C, right? Let's see what happened. Wait a minute, and the C is come out, right? So here what we got, A bar B, it is coming out, and here it is going to be A bar B, right? Such that your borrow output is going to be what? So here we got A bar B plus, right, A bar B plus, and here I got A X naught with B, right, into C. Actually I got some other expression. Let's try and check whether it is correct or not. Let's see, that is A bar B plus, and if I reduce this one, that is going to be A bar B bar plus AB into C, right? Such that I'm going to get A bar B plus A bar B bar C plus ABC plus ABC, and here what we are getting, if we are extending this one, that is going to be A bar, this is B bar C bar plus B bar C plus BC bar, and plus here we are getting BC, such that it is going to be A bar B bar C plus A bar B C bar plus here we are getting BC, right? So here we are getting BC. Did I got the same answer? A bar B bar C is, yeah, A bar B bar C I'm getting. ABC, yeah, I'm not getting actually. Did I make any mistake in the borrow? I think this is correct only, right? So we should take A bar here and we have to multiply in the sense. So here I have to take complement for okay, fine. Borrow came up last expression wrong, sir. Came up, ma'am. Yeah. Please let me check it once because that's why I'm not getting the answer here. Borrow என்ன பண்ணிருக்கோம்? Wait a minute. Circuit is correct actually because I know this one. This is the standard circuit. I think we made mistake somewhere in the borrow. Let me do it again. What we got 0 0 0. Let me do it by myself. 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1, right? First in this case we don't have any borrow. 0 minus 0 0 minus 1 is not possible, we have borrow. This is not also possible, we have borrow. This is also not possible, we have borrow. And here it is possible, no need of borrow, no need of borrow, no need of borrow. Here we need borrow, right? So 1 2 3, yeah, let me register. 0 I don't have any variable, 1 I have, 2 I have, 3 I have, and then 4 I don't have. 4 I don't have, na? Yes. 5 I don't have, 6 I don't have, 7 I have, right? Came up, that is correct only, na? What's wrong with me? 1 minus 1, that is 0. Yes, of course, that is correct. But what we consider here, A bar, A. This is going to be B bar, C bar. This is going to be B bar, C. This is BC. This is BC bar, right? So let's see what happened. If I'll group this one, what I'm going to get? I'm getting BC, right? Plus, for this person, we are going to get, okay, let me group this one first. If I'll group this one, I'm getting A bar, the common term is C, right? Plus, if I'll group these two, what I'm going to get? I'm going to get A bar, that is B, right? A bar B. Now, here, what I got? Did I got the same expression? The thing is, now I have to extend this one, right? Anyway, this is the minimized form of this one. Wait a minute, let me write them separately. This is going to be A bar B bar C, A bar B bar C, plus, guys, please 1 second, please be patient, right? Let me bring the answer. So A bar B bar C, is it visible to you all? Yes, that is visible. So let me write A bar B bar C. Next, please ping me if I made any mistake. Again, that is A bar B C, plus last one is what? A bar B C bar. Fine. And here for this expression, what we got? I got A B C, correct? Okay. Now, if I am putting this function, here I got A x nar of B into C. Yes, of course, that is correct. So let us check. Let me check by myself, right? So here our borrow is going to be, here what I got? A xr of B, na, A bar B bar plus AB into C plus, in this case we got A bar B. This is correct, A bar B is correct. Yeah, this case is over, right? So we are getting A bar B only, right? So we are getting A bar B. Now what we are going to get, if I will reduce this function, it is going to be A bar B bar C plus ABC plus A bar B, right? So let us consider A bar B C bar also, right? Let me cross check. That is A bar B bar C, A bar B bar C, and ABC, yes, ABC, and then A bar BC, yes, A bar BC, A bar BC bar, A bar B bar. Okay, fine, that is correct only. I made small mistake. Okay, circuit is correct. Now just to take this one, I think while writing the expression I made mistake. Now we got the answer, right? Okay, just we can write, that is going to be what? A xr of B, that is what I am getting with the C, plus A bar B. That is correct. Just keep this with you. Fine. Okay, so let me rub this one. So this is how we are designing full subtractor, right? Now what is our next task? I hope you all remember, and in our previous case, when I was discussing about the full adder, right, I told you in full adder there is a big demerit, right? So what is the drawback of the full adder? In each and every time we can add one bit with another bit, right? And the thing is, you cannot add more number of bits, first drawback, right? And the second thing is, when we are going up with the full adder, if you have any carry, right, per carry on the generate agudha, see there till now I was segregating the carry from difference. So if you take full adder circuits, we are getting two people, one is sum, another one is carry, right? Do I consider do we are considering do we consider both of them? No, we are not considering both of them, right? We are segregating them. That is, in the sense, carry generated while performing the addition, carry will be added with the next MSB. But we are not adding like that in case of full adder circuits, right? So in order to complete the operation, carry on the adutha bit la add aganum. If carry will be generated, then immediately that carry should be added with the next MSB bit, right, while traveling from LSB, right? So in order to perform that, that is, in order to complete the operation, right, full adder will be again extended as parallel adder, right? So our next task is we have to design parallel adder circuit, right? So let us do that one. Take the parallel adder, right? So keep the heading, we are going to design parallel adder circuit. Okay, now what do I mean by parallel adder? Parallel in the sense, full adder circuits are going to be connected in parallel, right? So full adder circuits are going to be connected in parallel. You can also use off adder circuits, that's our wish only, right? We can also use off adder circuits, right? Yeah. Now let's start our operation with the full adder circuit. That is parallel adder we are going to design with the help of full adder. First, basically we have to understand the operation of the parallel adder. That is enough, right? We don't need to think too much. What we are performing, that is the what type of operation that we are going to perform in parallel adder. Now we are going to add the carry with the next sequence. Listen guys, let's start from LSB. Let's start from LSB, right? So let me consider full adder circuit, right? In full adder circuit, initially we need 3 bits. For an example, I am considering bit A0 here, initial bit B0. With this, I am also considering C0, right? Usually our bits FDL, right? So our bits can be written as A, B, C, correct? So first combination here is 0, 0, 0. Now we have to consider these 3 people, right? So we are considering these 3 people. Now C denotes the carry that is already being generated, but carry won't be initially generated. So the value of C0 will always be set as 0, right? Initial carry is always 0. Now combinedly, right? So these 3 people will generate 2 things here. One is sum, another one is carry. That is called C1. Let me call it as C1. Now what we are going to do? The thing is, we are going to consider the second person. That is, let me take one more full adder circuit. Let us take one more full adder circuit, and the carry that we are generating in the previous full adder will be added here. With this, we are considering next set, that is called what? A1, B1, C1 is being added here, right? Again, the second sequence, right? So in this addition, it will generate 2 things. One is sum, another one is carry, right? So again, what will happen, if you want to differentiate them, you can say like this: sum S0 and S1. Again, let us consider the next one. Let's start our operation. This carry will be added here. And we have to continuously perform this operation until the arrival of the last one, right? So let me add this one. This is going to be what? A0, A1, that is we are going to consider A2, B2. So we have to repeat this operation until the arrival of the last operation, that is last bits, right? So that is going to be S2, and this is going to be carry C2, carry C3. Carry is going to be C3 now, right? Now this operation is being repeated. Do you understand what I am doing here? First 3 bits are being considered here. We are passing them through the full adder. Full adder will generate 2 things. One is sum, another one is carry. Sum is our output, just you can keep it, but carry is not the output. Carry should be added up with the next bits. So we are continuously performing the same operation until the arrival of the final bit, right? So the final is what? We are going to consider AN, BN, and here we are going to consider Cn, such that it will going to generate the next output, right? So its next output are going to be what? That is Cn plus 1 is going to be the final output, right? And that is a final carry, and this is going to be the final output Sn. Clear? So that is how we are performing, right? Parallel adder operation. That is parallel operation. But the drawback is here, each and every full adder circuit will generate a delay, that is called propagation delay. Each and every full adder circuit, right, will generate. See, in each and every full adder circuit, if you notice, just to take the full adder circuit, what we have done, Full order circuit in the sense it will be the combination of off order circuit. One off order circuit will generate TPD propagation delay. The propagation delay offered by single off order circuit is called TPD. But whereas in order to design the full order circuit, we are going up with the two set of off order circuit such that the net propagation delay always will become twice of TPD. Whereas, right, in order to know the complete time delay, we will have to multiply it by number of bits. Clear? So that is going to be the total delay that we are going to consider, right? So in order to perform parallel operation. So the conclusion is, what I would like to consider here, see, it is going to be 1 TPD, that is, it is only twice of TPD when we have only one full adder. Suppose if I am considering n full adder, then it will be multiplied by n, right? So the total propagation delay or the total delay, right, that we are getting in order to receive the output in case of parallel adder circuit is going to be what? So the total time taken by the circuit to produce the output is going to be twice of n into TPD, right? So that is the total delay generated by the parallel adder circuit. I am repeating once again, in one set of full adder circuit, we have two set of off adder circuit. Each and every gates will create a certain delay that is called propagation delay, right? Now, because of that propagation delay, if I will consider one complete full adder circuit, in one complete full adder circuit, we are having two off adder. So one off adder will generate 2 PD, then the total, if one off adder will generate TPD, then the total, right? So total full adder circuit delay is going to be twice of TPD. Why? Because two off order circuit combinedly will create one full adder. So one off order delay is 2 PD, then two off order delay is twice of, that is, I'm sorry, my mouth is again murmuring, I know. One off order will generate TPD delay such that we have two off adder in one full adder, yes or no? So the total delay will be twice of TPD, that's all. So one full adder will generate twice of TPD propagation delay. If I'll consider n full adder, in order to add two n bits, right? So in order to add two n bits, we are considering what? We are considering n full adder circuit. So the total delay generated by the circuit is going to be twice of n into TPD, right? So from this, the frequency of the circuit can be written as 1 upon twice of n into TPD, because we all know time and frequency are always reciprocal to each other. I hope things are very clear to you all. Clear? That is how we are performing parallel operation. But the drawback of the parallel operation is it is consuming more time, right? So delay is the biggest issue with the parallel adder circuits. So in order to avoid this issue, what shall we do? Let's continue our operation, right? So in order to avoid the issues with the parallel adder circuit, we are looking for the next type of circuit is called what? Carry look ahead adder, right? You might be heard that word already. That is called what? Carry look ahead adder. Abdina meaning enna? The thing is, guys, listen, I'm just raising the question against of you. Why we are facing this delay? நமக்கு ஏங்க இங்க டிலே வருதோ? see there, first இங்க பாருங்களேன், இந்த செகண்ட் ஃபுல் ஆடர் சர்க்யூட் வந்து ஆப்ரேட் ஆகணும் அப்படின்னா ஃபர்ஸ்ட் இந்த ஃபுல் ஆடர் சர்க்யூட் வந்து என்ன பண்ணா இதோட ஆபரேஷனை கம்ப்ளீட் பண்ணணும். இது ஆபரேஷனை கம்ப்ளீட் பண்ணாதான் இதுல இருந்து கேரி வருதா இல்லையா அப்படிங்கிறது இந்த ஃபுல் ஆடருக்கு தெரியும். இங்க இருந்து கேரி வராதுன்னு தெரிஞ்சா இது இமிடியேட்டா ஒர்க் பண்ண ஆரம்பிச்சிடும். ஸோ இட் இஸ் வெயிட்டிங் ஃபார் சம் ஒன், ரைட்? ஸோ அங்கிருந்து இப்போ இந்த மேரத்தான்லாம் வந்து வைப்பாங்கல்ல, நாட் மேரத்தான், இன் அத்லெட்டிக்ஸ், ரைட்? வி ஹவ் அந்த 400 மீட்டர்ஸ்ல வந்து தெர் இஸ் ஒரு 4 குரூப்பா பிரிச்சுட்டு ஃபர்ஸ்ட் 100 மீட்டர் ஒரு குரூப் வந்து ஓடும். அதுக்கப்புறம் அங்கிருந்து வந்து ஒரு கையில வந்து ஒரு டேப் மாதிரி கொடுத்துருவாங்க, ரைட்? லைக் ஃபிளாக் மாதிரி கொடுத்துருவாங்க. அந்த ஃபிளாக் வாங்கிட்டு another group will again run, again third group, again fourth group, இந்த மாதிரி கொண்டு வருவாங்கல, ரைட்? இஸ் இன் காம்படிஷன். சேம் திங் will happen here. அப்ப என்ன ஆகுனா one group is waiting, one set of full adder is waiting for the previous one. In the previous one ல இருந்து கேரி வந்துருச்சுனா immediately this will operate. But the third full adder is waiting for the second one, because till now there was no carry generation. Once carry will be generated here, immediately this full adder will work. Like that in each and every full adder circuit, if you observe, so third full adder is waiting for the first and second one. Again fourth full adder will waiting for the first one, second one, third one, because first one has to generate the carry, and then second one has to generate the carry, and then third one has to generate the carry. The sequence will be continuous. If you go up with the last one, அப்ப ஃபைனலா இருக்க full adder பத்தி யோசிச்சு பாருங்க. It has to wait n times of டோட்டலா இருக்க எல்லா full adder சேர்த்து இது வெயிட் பண்ணிட்டு இருக்கு. ஓகே, பொறுமையா வாங்க, வந்துட்டு எனக்கு சொல்லுங்க. Finally I will work, right? So what is the drawback here? The drawback is this carry generation is the problem with me. I understood, right? If I remove these carry issues, then automatically each and every person will work separately. Do you all agree with me? இப்போ இந்த கேரியை பத்தி நான் வரி பண்ண தேவையில்லை அப்படின்ட்டு நான் உங்ககிட்ட சொல்லிட்டேன். நான் என்ன சொல்றேன் அப்படின்னா, செகண்ட் ஃபுல் ஆடர் கிட்ட போயிட்டு நீ என்னோட கேரிக்காக வெயிட் பண்ண வேணாம், நீ செப்பரேட்டா ஆபரேஷன் பண்ணிக்கோ அப்படின்னு நீங்க சொல்லிட்டீங்கன்னா immediately it will work. அப்ப என்ன நடக்கும் அப்படின்னா, சர்க்யூட் நீங்க ஆன் பண்ண உடனே all full adder will work at the same time. no one will going to create the delay. So that is called carry look ahead adder. And the carry நம்ம என்ன பண்ண போறோம் அப்படின்னா that problem will going to be eliminated with the help of carry look ahead adder. I am repeating once again, each and every full adder circuit will create certain carry, right, with some delay. இப்போ second circuit என்ன ஆகும் அப்படின்னா the next full adder circuit is waiting for the previous full adder carry response. If there is no carry generation between them, then definitely you can avoid the delays. This full adder no need to wait for the previous one, this full adder no need to wait for previous one, like that this nth full adder no need to wait for the n-1 full adder operation. So we can let them in order to perform the operation separately. That is called carry look ahead adder. Clear? So this drawback is going to be completely nullified. Okay, let's design the last circuit is called carry look ahead adder. I hope things are very clear to you all. In digital there are no things to understand. Even me too, I am requesting you all, I never used to memorize these things, right? So whichever that is my mind will playing, that is because there are no things. Once you understand, you can draw the circuit and you can just to play with that, right? Fine. So our next target is we have to generate carry look ahead adder, right? And one more thing is you don't need to memorize parallel adder அப்படினு ஒன்னு இருக்கு, அதுல எப்படி தான் நம்ம ஆபரேஷன் பண்ணனும். You don't need to memorize anything. Without knowing anything, just by knowing the proper operations that we are performing in digital, you can solve all questions because your questions are very easy. Right? Fine. What is our next task? We have to design carry look ahead adder. I don't want this one. Still I'm having a problem. See, first of all, I am requesting you all to see the drawbacks of the off adder. So there was some drawback. That drawbacks was overcome by full adder circuit. But in full adder also, again I had a drawback. I was unable to add more number of bits. At the same time, carry cannot be added with the next bits, right? So that is also problem. In order to overcome that one, I was going up with the parallel adder. But in parallel adder, one more big issue had been raised against of the parallel adder. That is called what? Propagation delay. In order to avoid the propagation delay, finally we are going to design a perfect circuit that is called carry look ahead adder. Clear? That's all. It's over with this carry look ahead adder. Okay, finally we are going to design carry look ahead adder. Fine. Now it's very simple. For that, in order to understand this carry look ahead adder, I am taking a simple full adder circuit, right? So only take one complete full adder circuit. In order to design the full adder circuit, right, I told you we are just going up with what? XOR gates only. So let me take, I'm in need of 2 XOR gate, that is 2 off adder circuits requested in order to design full adder circuit. Already we saw, right? So let me complete. This is going to be first off adder. Now let us consider one more off adder circuit here in order to continuously perform the operation. Next, what we are going to do, let me take one more terminal here, and these two junctions grouply will give us the second off adder. Now with this I am in need of one more OR gate in order to complete the, what I can say, this is going to be sum, this is going to be what? Carry, right? We know. Now let me slowly introduce few more things here. Now instead of considering A, B, C directly, let me consider high bits or n bits. Let us consider n bits, Bn, An, Cn. Let us consider n bits such that output of the first gate is going to be An plus Bn, this XOR gate, right? So that is called propagation, right? So that is the propagated output, right? So the propagated output of this XOR gate is simply called An XORed with Bn. So let me call it as simply, this is called as propagated output of the first XOR gate, right? Propagation delay. With the propagation delay, we are generating the propagated output, right? So similarly with this propagation, right, so carry will be generated here. So this off separator here we are generating the carry, so that is called generation. This is called generation. Whereas the value of the generation, let me consider Gn, so that is going to be An into Bn. That is the generation. We are considering n bits or high bits. You can consider anything that you want, right? So let me pass Cn through it. Here it is going to be Cn, such that output of this one Sn is going to be, let's try and bring the answer. An XORed with Bn XORed with Cn. Similarly, carry can be written as Cn plus 1. See, initial carry already we are considering. I cannot directly write Cn, right? Just now I wrote in the parallel adder, the last carry can be written as what? Cn plus 1 only, right? So I'm writing in the same way, Cn plus 1, right? Which can be written as, right? So the output of this person is what? Here we got An XORed with Bn, An XORed with Bn, and this is going to be what? Cn. right? So let's multiply it with the Cn, and this is here I am getting Gn, right? So that is called generated value. Now notice this one, this is nothing but propagation. I said this is nothing but propagation, so let me simplify. So that is going to be propagation with the Cn. Okay, this is generated carry, such that it output is going to be, is it visible to you all? Shall I write? Yes, we can write here. So that is such that its output is going to be Pn Cn plus Gn. Clear? So that is the output of the carry, right? Sir, why are you considering these things? Now my XOR gates are generating the propagation, whereas this is carry generation. Now with the help of these people only are creating this carry here, right? We're taking the responsibility for this carry, and I'm facing some delay with this. Now in order to overcome this delay, what shall we do? Let's take that carry outside, right? So let us take that carry outside. Guys, listen, we don't have any problem with this sum, right? நம்ம லாஸ்ட்ல parallel adder பத்தி பேசிட்டு இருக்கும்போது, right, I was just talking about what carry. ஃபர்ஸ்ட் parallel adderல ஜெனரேட் ஆகிற கேரி, ஃபர்ஸ்ட் ஃபுல் adderல ஜெனரேட் ஆகிற கேரி செகண்ட் ஃபுல் adderக்கு போகணும், செகண்ட் ஃபுல் adderல ஜெனரேட் ஆகிற கேரி தேர்ட் ஃபுல் adderக்கு போகணும். அப்போ ஒவ்வொரு ஃபுல் adder என்ன பண்ணணும் அப்படின்னா அதுக்கு முன்னாடி இருக்க ஃபுல் adder ஆக்டிவேட் ஆகிற வரைக்கும் வெயிட் பண்ணணும். தட் இஸ் கால்டு ப்ரொபகேஷன் டிலே. அதை ஓவர் கம் பண்ணோம் அப்படின்னா இந்த கேரியில் வர இஷ்யூஸ் வந்து நம்ம சால்வ் பண்ணணும், ரைட்? ஸோ லெட் us see. Now I am just putting n equal to 1. Listen, just we got some output for carry, right? So let me rub this one off. I hope you all have drawn this circuit. It is video only na, so you can just replay and you can draw the circuit if you don't, no issues. I think Cn plus 1 can be written as Pn Cn plus Gn, correct? Okay, let us raise. Let me put n equal to 0 first, because C0 is known for us, right? Initial carry is known for us, right? If I'll put initial carry is 0, initial carry will be 0. If I'll put n equal to 0, then you will get C1 is equal to, listen, n equal to 0. 0 plus 1 will become 1. So it is going to be n equal to 0. I'm getting P0, C0 plus G0. Now we know the initial generation, we know the initial propagation, initial carry also known. By substituting all the values, we can find out the value of C1 directly. Now repeat, let me put n equal to 1. If I'll put n equal to 1, then this is going to be C2. This is going to be P1, C1 plus G1. Clear? Yes, I hope this is correct. Now the thing is, let me reduce the circuit further. P1 into, we know the value of C1 na? C1 inga substitute pannunga, that is going to be P0, C0 plus G0, such that its output is going to be, okay, let us just stop with this, that is enough, right? Now let me put n equal to 2. If I'll put n equal to 2, then what happens? If I'll put n equal to 2, then it is become C3. C3 will become P3, sorry, n equal to 2, so that is going to be what? P2, C2 plus G2. Now see there, if you notice this one, P2, C2 can be replaced by, in the previous expression we got P1 into P0, C0 plus G0. That is the expression that I got for what I can say C2, right? So plus we have to consider G2. Guys, did you notice the one more thing here? I told you, while in the parallel adder circuit, I had a drawback. That drawback is each and every full adder circuit are waiting for the previous one. But now, if you notice this one, the carry generated by the second person, right? So this C1. C1 is depending on the value of C0, of course, and carry of C2 also depending on the value of CC. It is clear, not that one. C2 also depending only on the value of C0, just observe. C3, just observe this one. C3 la yaar irukka parunga, only C0. நீங்க அடுத்த எக்ஸ்பிரஷன் எழுதுனீங்க அப்படின்னா அடுத்த எக்ஸ்பிரஷன்ல C4 வரும். C4க்கு நீங்க என்ன பண்ணலாம்? C4 குள்ள C3 வரும். C3 ஓட எக்ஸ்பிரஷன் we can write in terms of C0, like C5, C6, C7. அப்ப என்ன ஆகும்? Each and every carry does not depending on the previous adder, it is only depending on the initial carry. Initial carry will be 0. I told you already. Directly you can substitute the initial carry, you can perform the operation separately. Happy now? See there, I am repeating. Did you notice this observation? See there, C1 is nothing but the carry of the second full adder. C2 is nothing but the carry of the third full adder. So you can just continue your operation. C0 is the carry of the first full adder. Now I know the value of C1 separately. I also know the value of C2 separately, C3 separately, C4, C5 up to Cn. We know the carries values separately. So we can directly substitute them. Just they are only depending on the value of C0. They are not. See that. Just observe the expression. C1 is depending on C0 and C2 also depending on the value of C0. C3 also depending on the value of C0 only. If you further continue until the value of the last carry, each and every carry are going to be depends on only first one, but that first one value will be 0. So what is the conclusion here? So the carries of the full adder circuits are not depending on the previous now. So that drawback is completely eliminated. Are you happy? Yes. So the best option is we have to go ahead with the carry look ahead adder. We got this one, right? Now you can just simply draw the circuit. Yeah, let me rub this one. Now you can simply understand. Up a parallel adder will become, there is no relations between them. Now you can separately consider them. First adder will be separated from the second adder. Now you can perform the operation between them separately. You don't need to, there is no contact between them. Initially you can register A0, B0, C0, A1, B1, C1, A2, B2, C2 until they are of the last bit. You can just proceed further and you can simply collect its correspondent sum output. Sum and carry. Clear? So you can simply collect its correspondent sum and carry. You don't need to be panic about idhula carry vandirukka illaya idha vechi na inge eppadi generate pannadhu. We know the value of C1. We know the value of C1. We don't need to connect these 2 points. Directly C1 will be registered here. Because already we got C1 in terms of C0. Clear? Similarly, you can perform, that is C2. This is, let me call it as S0, S1. And that C2 will be directly registered because we know the value of C2 also. We can directly register in terms of C0. It is not depending on the previous full adder. So the drawback that the propagation delay had been completely nullified with the help of carry look ahead adder. I hope things are very clear to you all. Just to make very clear notes. Okay, so let me rub these things. Yeah. Okay, I did a few more observations, right, today. I saw few questions, right, very few questions, and in IES only, right, you are tested for this full adder circuit for different combinations, right? So I just did that observations and I have drawn them. I had collected some things by myself. I'm just giving those things from the observations. You please make notes. Wait a minute, I don't know where I have wrote this one. Yes, that is here, right? Now the thing is, listen guys, we are in parallel adder, right? So we are in parallel adder only. So still we are in parallel adder, but we are in parallel carry look ahead adder, right? Anyway, let us take the parallel adder circuit. Parallel adder na munadi paathom illaya, carry look ahead adder ku munadi design panadhu. In parallel adder circuit, right? So in order to add, right, if you are in order to perform, that is 2 n bits operation, right? In order to add n bits, right, while performing n bit addition, right, the question is number of full adder circuits that it should be required. Number of full adder circuit. First question is how many full adder circuits are required in order to add 2 n bits, right? So the answer for this one, answer for this one is n full adder circuit. We can directly write that is n full adder circuit, right? So the second type of question that you are asked, right, they were given the, I think in terms of, listen, off order link kuduthiranga. We all know, listen, let me sit. N, see this full adder நீங்க வேற எப்படி எழுதலாம்? Full adder circuit அப்படினா it is 2 off order. Of course that is correct. Yes or no? 2 off order plus 1 OR gate. Am I correct? Of course that is also correct. In order to perform, right, n operation வந்து நீங்க perform பண்ணனும் அப்படினா இந்த full adder circuit க்கு பதிலா நீங்க என்ன போட்டுக்கலாம்? Full adder circuit just remove பண்ணிட்டு n times of twice of off order plus this full adder circuit. One full adder circuit will be equal to what? 2 off order circuit plus 1 OR gate. Do you all agree with me? So that is correct statement. So they had given this statement like this. Okay, so let's continue our operation. Next one is, suppose if you are avoiding this OR gate. இப்போ இந்த OR gate இல்லாம if you are trying to bring the answer only with the help of off order and full adder, then I got one more observation. Let me I don't know where I have written. Yeah, that is going to be n minus 1 full adder circuit plus I got 1 off order circuit. I'm repeating once again what I'm doing here. The thing is, in order to design n bit parallel adder circuit, addition காக நம்ம design பண்ண போறது, either you can go ahead with the n full adder circuit or you can go ahead with the n times of 2 off order plus 1 OR set circuit, that is 1 OR gate, right? Or otherwise you can go up with the n minus 1 full adder circuit plus 1 off order, right? Because in examination you were tested for some chilly 1 more questions. Today only I had noticed in IES, right? Yeah, IES questions, right? So let's see, and some other state government exams also you were tested this type of questions. And in one exam I found one more lesson. Let me write, wait, where I don't know. Yeah, wait a minute. Yeah, next I found, see, let's continue our operation. we can also write which is equal to, right, I got, so n minus 1 times of this relation should also be equal to, right, its equivalent is, see once again in the full adder circuit this full adder circuit can be replaced by twice of half adder plus 1 OR gate na. Yes, that is the next observation that I got. So plus, and they said that is 1 half adder, that is correct, right? That is why I forgot actually. That is what I had been observed. That is one of the state government exam, but not our Tamil Nadu, right? Well, let's see. Next I got one more observation, that is it can also be equal to, yes, OR gate half adder. I have seen one more observation, that is twice of n minus 1 half adder circuit plus, right, I got see all our observations only. I just noted these things on the paper. I did this one, I got the results correctly, and then I just tried with the answer, I got the correct result, right? So you don't need to be panic, just you can observe these things, right? Finally I got one more result. Let me write that one, that is general observation 2n minus 2, right? So please wait a minute. Half adder circuit plus, we can also bring the relation with the n minus 1 OR gate plus I got one more relation, that is 1 half adder. Right? These are all observations, postulates, right? So just I have done this one, right? So in our today session only, right? So just that is in different examinations you are tested with the different approach, right? Not all these things, I got very few things, right? So let me denote this one you are tested, and this one you are tested, right? And this one you are tested, and these things I had collected for some other books, right? So just you can make a note of it, right? So that might be helpful to you while solving the problems. You may be tested for some 1 mark theoretical questions, right? Okay, so in order to design, right, in order to perform, in order to add 2 n bits, right, in parallel adder circuits, how many full adder circuits are required, or how many half adder plus OR gates are required, or how many half gate plus, that is half adder plus full adder circuits are required, in the many questions கேட்டாங்க அப்படினா you will have to just to proceed with the this sequence. Clear? Yes, I hope things are very clear to you all. Now let us start the next one. So wait a minute, is it going good? Class okay va? Yeah, I think it's going good. Let's start our next type of operation. Is called, we are going to do multiplexing now, right? So let me rub this one. Happily we are going to start the next chapter, sorry, next part, that is the second operation, that is we are going to discuss about multiplexer, right? Multiplexer and demultiplexer, right? Now what we are going to do here, in multiplexer we are going to select the data, in demultiplexer we are going to distribute the data. Now what do I understand from these two? Multiplexer நம்ம என்ன ஆப்ரேஷன் பண்ண போறோம் அப்படின்னா, ஃபர்ஸ்ட் வந்து ஃபார் an example, இப்போ வந்து நம்ம இங்க இருந்து just I am giving my speech, ரைட்? இப்போ நான் இங்கே ஸ்பீச் வந்து கொடுத்துட்டு இருக்கும்போது என்ன ஆகுது அப்படின்னா, ஃபார் an எக்ஸாம்பிள் இதில் வந்து மொபைலில் வந்து மொபைல் ப்ளஸ் இப்போ நீங்கள் வாட்ச் பண்ணிட்டுருக்கீங்க இல்லையா, அந்த மொபைலில் வந்து நீங்கள் வாட்ச் பண்ணிட்டு இருக்கும்போது என்ன ஆகும் அப்படின்னா, யூ கேன் ஹியர் மை வாய்ஸ், ரைட்? ஆஸ் வெல் அஸ் இப்போ உங்கள் மொபைலில் வந்து தெர் ஆர் சோ மெனி திங்ஸ், யூ மே யூஸ் அ டேப்லெட் ஆர் லேப்டாப், விச் எவர் தி திங்ஸ் தட் யூ வாண்ட், ரைட்? யூ கேன் ஜஸ்ட் கீப் இட். அங்கே மல்டிப்ளெக்ஸரோட ஒர்க்கு டிமல்டிப்ளெக்ஸரோட ஒர்க் வந்து என்ன அப்படின்னா, யூஸ்வலி multiplexer will work at the sending end, right? So I am just sitting in front of the camera. Now here we are going to have some certain multiplexer. That certain multiplexer will going to select the specific data, that is my speech signal. Now at the receiving end there is one more plexer, that is called a demultiplexer. That demultiplexer will receive this signal and then it will distribute the signal to you all. That is called a data distributor. So distributor in the sense, not only how many guys are watching this channel? So almost nearer 30 people are watching, right? So what is the conclusion here? You 30 guys are going to receive only one signal. So that is called a data distribution. So demultiplexer work is, it has to distribute the data. Multiplexer work is, it will pick the data and it will transmit, right? So there are two people that we are going to consider. One is we are going to, right, with the help of multiplexer we are going to collect the data. With the help of demultiplexer we are going to what? Distribute the data. Okay, fine. I hope things are very clear to you all. Now அப்ப நம்ம என்ன பண்ணோம், ஒரு மொபைலை வந்து நீங்க எடுத்துக்கிறீங்கன்னு வச்சுக்கோங்க. ஃபார் எக்ஸாம்பிள் மொபைலில் வந்து உங்களோட ஒரு மெமரி கார்டில் you might stored some 500 songs. ஒரு 500 songs வந்து நீங்கள் சேவ் பண்ணி வச்சிருக்கீங்க. இப்போ நீங்கள் என்ன பண்ணுறீங்க அப்படின்னா, மேலே போயிட்டு சர்ச் பாக்ஸில் 500 சாங்ஸை வந்து நமக்கு தேவையான சாங் வந்து செலக்ட் பண்ணுறதுக்காக ஸ்க்ரோல் பண்ணிட்டு இருக்க முடியாது, ரைட்? ஸோ இன்ஸ்டெட் வி ஹவ் ஒன் மோர் ஆப்ஷன். நீங்கள் எல்லாரும் பார்த்தீங்கன்னா டாப் கார்னரில் சர்ச் அப்படின்னு ஒரு ஆப்ஷன் இருக்கும். யூ கேன் ஜஸ்ட் கோ தேர் அண்ட் யூ கேன் டைப் விச் எவர் தி சாங் தட் யூ வாண்ட், ரைட்? ஸோ அதை நீங்கள் டைப் பண்ணும்போது ஆட்டோமேட்டிக்காக அது என்ன பண்ணும், இட் வில் அவுட் ஆஃப் தட் 500 சாங்ஸ் நீங்கள் டைப் பண்ணுற கோடிங்கில் இருக்க டேட்டாவை மட்டும், சாங்கை மட்டும் பிக் பண்ணி எடுக்கும். தட் இஸ் கால்ட் டேட்டா செலெக்ஷன். right? Now the conclusion is what? I need a perfect line. எனக்கு ஒரு லைன் தேவைப்படுது. அந்த லைன் யார் அப்படின்னா நீங்க செலக்ட் பண்ற ஸ்பெசிபிக்கான ஒரு டார்கெட், ஒரு டாஸ்க் வந்து பெர்ஃபார்ம் பண்றதுக்கு ஒரு லைன் தேவைப்படுது. that is called data selector. This data selector line will always be available in both multiplexer and demultiplexer. And the second thing is what? we are going to consider many input lines and one output line. The best example is hearing songs. இப்போ நம்ம மொபைலில் வந்து 1000 சாங்ஸ் இருக்கு அப்படின்னா கேன் யூ ஹியர் 1000 சாங்ஸ் அட் ஏ டைம்? நோ. ஸோ பட் சைமல்டேனியஸ்லி வி கேன் ஹியர் திஸ் சாங். அப்படின்னா மீனிங் என்ன? வி ஆர் கோயிங் டு செலக்ட் ஒரு 1000 சாங்ஸ் வந்து பிளேலிஸ்ட்ல இருக்கும். 1000 சாங்ஸ் ஆர் அவர் இன்புட் ஒன்லி. விச் எவர் தி சாங் தட் வி வாண்ட் வி கேன் ஹியர், பட் வி cannot play two songs, that is we cannot hear two songs at a time in a single mobile. So the conclusion is, right, so the conclusion is we are going to pick with the help of data selector. There are 1000 inputs, right? So there are 1000 inputs, but we are going to select only one output at the time. That is called multiplexer work. So for multiplexer என்ன பண்ணோம் அப்படின்னா in general, right? So in general, just to remember, right, ஒரு சாங்ஸ் எடுத்துக்கிட்டு அது அப்படியே அதை வச்சு நம்ம டிசைன் பண்ணிடலாம். Circuit can be designed, right? So with the help of, for an example, right, so we are going to consider, that is we are going to design multiplexer. First we are going to design multiplexer circuit, right? So in general, right, so let me develop the general multiplexer circuit from the input side, right? From the input side we are going to consider 2 power n input lines with only one output line, right? So in the sense, if I am just replacing n equal to 1, we are going to consider 2 input lines. Let us assume we are having only 2 songs. If I am replacing n equal to 2, it means we are having 4 songs. If I am replacing n equal to 3, it means we are having 8 songs. If I am replacing n equal to 4, 16, it means I am having 16 songs in my mobile, right? Though the thing is, in order to select these lines, right, so here we are going to consider n data lines, input lines, or we can simply write that is input lines, that is 2 power n input lines. We can say that is called 2 power n input lines. Now with this we are going to consider one more variable, that is called what? Multi selector, right? So we are going to consider, that is called what? Data selector, right? Or we can simply call them as data selector. We can simply call them as data selector, right? So for an example, let us consider, we are going to consider m data selector here. The number of lines that we are going to consider is simply called m data selector. We are going to consider m data selector, and the approximate relation between these two guys, right? The approximate relation between these two guys, we can simply say, right, say, wait a minute, let me write n is equal to approximate relation, n is equal to 2 power m, the relation between input lines and data selector, that is the approximate relation between them, right? So from this, if you want to know the value of m, so we can say log base 2 n will give you number of data selector. If n bit is given, we can easily find out the approximate number of data selector line that it should be required in order to perform the multiplexer operation. Anyway, let's continue our journey with this. I said we are going to consider only one output in multiplexer. Clear? So what I had been told you, there are 1000 songs in the input side, but we cannot hear all these songs. So with the proper data selector, இப்போ டேட்டா செலக்டர் என்ன பண்ணும் அப்படின்னா நீங்க எந்த சாங்கை டார்கெட் பண்ணீங்களோ அந்த சாங்கை போயிட்டு இந்த இடத்துல சர்ச் பண்ணி வெளில எடுத்துட்டு வந்துடும். ஃபார் எக்ஸாம்பிள் நீங்க என்ன பண்ணுவீங்கன்னா டைப் பண்ணுவீங்க, ரைட் சார் there are 1000 songs are there, now you would like to hear only one single song. அதை நீங்க சர்ச் பார்ல போயிட்டு நீங்க டைப் பண்ணிட்டு இருக்கும்போது என்ன ஆகும் அப்படின்னா ஆட்டோமேட்டிக்கலி டேட்டா செலக்டர் will work, it will start its initiates its work. என்ன பண்ணாடி நீங்க வேர்ட் டைப் பண்ண என்ன ஆகும் அப்படின்னா அந்த வேர்ட்ஸ் ரிலேட்டடா இந்த 1000 சாங்ல யார் இருக்காங்களோ அவங்கள மட்டும் பிக் பண்ணி எடுத்துட்டு வந்துட்டே இருக்கும். நீங்க பாத்தீங்கன்னா தெரியும், நம்ம அதை டைப் பண்ணும்போது என்ன ஆகும் அப்படின்னா நீங்க டைப் பண்ண லெட்டர், ஃபர்ஸ்ட் லெட்டர் டைப் பண்ணும்போது ஃபர்ஸ்ட் லெட்டர்ல என்னென்ன சாங்ஸ்ல இருக்கோ எல்லாமே கலெக்ட்ல வந்துரும். அடுத்து நீங்க செகண்ட் லெட்டர் டைப் பண்ணும்போது அந்த ரெண்டு லெட்டர் ரிலேட் பண்ணிருக்க டேட்டாஸ் வந்து முன்னாடி வரும். அகைன் 3 4 5 6 like while increasing, நீங்க number of letters increase பண்ண ஆட்டோமேட்டிக்கா ஒரு 5 letters நீங்க செலக்ட் பண்ணும்போது என்ன ஆகும்னா only one song அது முன்னாடி வந்து நின்றும். directly you can just push that button, it will play. Correct? Yes. So that is what your multiplexer will do here, right? Yes, it's over. So அப்ப என்ன ஆகும் அப்படின்னா data selector will going to select the specific data, that selected specific data will appear at the output side. Clear? That's all. So that is called multiplexer work. Okay, later we will discuss about demultiplexer. Right now understanding the multiplexer is much important and it's quite interesting too, and there are numerous questions in your examinations, right? I will solve plenty of questions are there in the examination. This is the most important area, should try to keep your attention, right? So let's continue our journey with this. Let me rub these things. Guys, this is approximated value only, right? This is not exact value. Yeah. So What is our first task? Let's start and design the multiplexers, right? Now let's see. First let me design 2 cross 1, sorry, let us consider n equal to 1. N equal to 1 abdina we are going to design, see, we are going to consider 2 power n input lines and 1 output line. If I am letting n equal to 1, it means we are designing 2 cross 1 multiplexer. So that is called 2 cross 1 mux, right? Anyway, mux can be represented in two ways. Either you can use a rectangular box or you can also use a trapezoidal box, right? So this is, let us consider like this, right? So there are two ways in order to design, that is you can represent the mux, right? So let us consider 2 cross 1 mux. This is going to be the output and these are all going to be input. Now see that we have to select, in order to select these two data, right? So the number of inputs that it should be required for us is only one line, right? So let me select, so let me do one thing. This is, let us consider S0, right? Now what your S0 will do, S0 will going to select only these two data, right? So if S0 will be 0, then first line will be selected. Let us consider input line I0 and input line I1, right? So in order to continue, right, if in the rendu line select panna appadina, I made of only one single line here. Now that single line will going to generate these two variables, right? So let us see, appo S0 க்கு நீங்க 0 போட்டீங்க அப்படினா automatically what will happen, when S0 is going to be 0, I0 will be selected. When S0 is going to be 1, I1 will be selected, right? So that is input data. This input data will be selected based on the value that we are giving in the data selector line, right? So that is called a data selector representation, right? So let's write the output expression. Similarly, we can also consider I0 here, I1 here, and this is the point where we are going to consider data selector, and this is going to be our output. Clear? So let's start our journey. Now let me consider, if S0 is 0, then automatically I0 will be selected, right? So I0 will be selected such that your output will going to be, right? So let me write the answer directly. Listen guys, output will become I is equal to Y is equal to, once again we are going to use SOP form, sum of product. For sum of product form la neenga output eludano appadina, zeros are not available in SOP. Zeros are not allowed in SOP, we can say like this, right? So zeros could not be allowed in SOP form, right? Such that what I have to do, when I am replacing S0 equal to 0, this S0 will going to select I0 such that output of the function Y become, it will be the combination of these two people, right? So the combination in the sense, first I have to, S0 will going to select I0 such that first we have to perform AND operation and then we have to perform OR operation. First we have to perform AND operation and then we have to perform OR operation, sum of product, such that product operation S0 into I0. I cannot directly consider S0 because since S0 is 0, in order to consider S0, I will have to take complement for S0 and then you can multiply it by I0 in order to select the data I0. Guys, I am repeating, in multiplexer there are nothing to learn. 2 means we have to consider 2 input lines. Its correspondent I am considering one selector line such that if selection is 0, then I0 will be selected. If selection is 1, then I1 will be selected. That's all. Okay, fine. Next, if I am putting S0 equal to 1, then what will happen? Automatically I1 will be selected. That is the order, right? So when I am putting S0 equal to 1, directly we can consider, because that equivalent value will be 1 only, na, into I1 will be selected. That's all. That is the output of the multiplexer. This is the output of the multiplexer, right? I hope things are very clear to you all. And you can also implement this multiplexer with the help of logic gates, right? How will you design that one? So let me do that one. Let me rub this one now. Yeah. Now logic gates in the sense, let me select a line is called S0. Let us select S0 line and let me select one more line that is called I0. Let us select one more line that is called I1. Now let us complete the circuit. Output is what? S0 bar into I0. First thing, from the I0 I will have to select a line, and from S0 also we have to select a line, but I am in need of S0 bar, so I am just putting one inverter here and then they will be multiplied together. Okay, let me multiply them just by considering one AND gate. Next I am in need of S0 into I1 such that this is S0, let us consider this is I1, so let us directly club them together and then we can just add them, right? So that is the implementation, right? நீங்க laboratory பண்ணீங்க அப்படினா இப்படி தான் பண்ணனும், labல, in case engineering students are being here, right? I think some people are there. Fine. So that is how you have to design, right? So in your laboratory, right? Here it does not require. That is how we are realizing what I can say 2 cross 1 mux. Let's raise the number of input lines. So let me consider n equal to 2. If I will consider n equal to 2, then automatically number of mux will become what? 4 cross 1, right? So let us consider. Anyway, output is fixed. Like your songs, right? நீங்க எத்தனை songs வச்சிருந்தாலும் one time we can hear only one song. Data selector, a specific data, right? Fine. So let us design the second type of circuit that is called what? That is 4 cross 1 mux. you please do it by yourself, because now I know you all have understand what we are going to do here, right? It's very simple operation. Let me raise. When I am considering n is equal to 2, right? So the second case, if I am increasing the number of bits, automatically if I'll put n equal to 2, then we are going to consider 4%, right? It means 4 cross 1 mux is going to be 4 cross 1, such that very important mux, right? You can observe almost 90% of the question from the mux will be framed from 4 cross 1 only, right? Now here you have to understand one thing. Some people will try to draw the lines, that is input lines எப்படி கன்சிடர் பண்ணிருப்பாங்கன்னா I0 first and then I1 and then I2 and then I3. In some cases in your examinations also they will go in the upward direction, first I0 and then I1 and then I2 and then I3. It does not matter how your lines are being arranged here. The thing is you will have to always go from ascend, that is always go in ascending order. I0 is first, I1 is second, I2 is third, I3 is fourth. That is the order, right? It does not matter at which position they are being placed, right? You can also club them together and you can also collapse them. It does not matter for me. Where is I0? I0 will be selected first, I1 will be selected second, I3 will be selected third, I0 will be selected first, I1 will be selected second, I2 will be selected third, I3 will be selected fourth. That is the order, right? Fine. Now in order to select these guys, I am in need of 2 selector lines, right? So let's start our journey with this. Total I am in need of 2 selector lines, so such that let us consider 2 power n, and anyway that is going to be what? Let me consider 4 cross n, 4 cross n, right? So in order to consider, that is 4 bits select pannodina, here I am in need of 2 selectors, right? So 2 lines should be required. So that is I0, I1, I2, I3, right? So and the output is going to be y. Let's see, sorry guys, this is 4 cross 1, 4 cross 1 mux, such that here we are going to consider 2 people, one is S0 and another one is S1, such that their combinations either they might be 0 0 or 0 1 1 0 1 1, correct? So we are going to consider 2 variables, that's all, right? So why? In order to select the 4 lines, at least I'm in need of 2 variables, right? So let's start our journey with this, right? So if I'm just starting our journey with this, so what I'm going to get, so let's consider this one. This is equal to, right? So first 0 0 na edhi select agum, which line? I0 will be selected, 0 1 I1 will be selected, 1 0 I2 will be selected, 1 1 I3 will be selected. That is the decimal equivalence, right? So let's write the answer in SOP form. Once again, sum of product form. SOP form in the sense zeros are not acceptable, so we should take complement for them, such that the output is going to be S0 bar S1 bar. When we are giving 0 0, I0 will be selected, so output will become S0 bar into S1 bar into I0, plus when we are giving 0 1, if I'll give 0 1, automatically I1 will be selected, such that output is going to be, see there, S0 we should take bar, and then for S1 we don't need to take anything, and then we have to consider I1, plus and then we have to take the third one is going to be S0, we have to consider S1 bar, and then we have to consider I2, plus last we are going to consider S0 S1, and here we are going to consider I3, Now if you want to realize these things in terms of logic gates, you can do it. I don't want to waste my time. You please do it by yourself, because already I told you how to, that is I taught how to draw that things. Okay, fine. So this is the output of the 4 cross 1 mux. So in the same way you can also realize what? 8 cross 1 mux, right? So let us see. Let me remove this one, right? For 8 cross 1 mux, output is 8 combinations, right? So you will have to do that one. Let me do it anyway. We have to understand 8 cross 1 mux in the sense totally we have to consider 8 lines. So let us consider I0, I1, I2, I3, I4, I5, I6, I7, right? Such that we are going to get 8 lines. I0, I1, I2, I3, I4, I5, I6, I think I have to, I had been written here. Yeah, that is going to be I7, such that 8 cross 1, that is 8 cross 1 mux. Anyway, output is 1 only, there is no changes, and here we are going to consider 3 lines. So let's raise the number of lines slowly, S0, S1, S2, such that 8 means we have to consider 3 possibilities, 16 means we have to consider 4 data selectors. Then only what will happen? See, in order to, inga 8 lines or 3 lines automatically 0 0 0, first line will be selected, 0 0 1, second line will be selected, like that 1 1 1 will going to select the 7th line. So automatically what will be the output? So let me write the first one. First one is going to be all are 0, such that it can be written as S naught bar, S1 bar, S2 bar, all are 0 into I naught, right? Into I naught. Like second 0 0 0, second combo is going to be 0 0 1, such that it is going to be what? S naught bar, S1 bar into S2 into I1, plus you can just continue these operations until the level of the last one. Final one in the sense all are going to be 1 1 1 1 1, such that it is going to be S0, S1, S2, and the last variable that we are considering here is called I7. Clear? So that is how we are bringing the final answer for multiplexer, right? So 8 cross 1 multiplexer. Like that, you can increase the number of multiplexer. Like you can consider, if I put 4, then that is n equal to 4. Automatically, what you are going to get? You are going to get 16 cross 1, right? Again, you can raise the number of n equal to 5, 32, n equal to 6 is 64, n equal to 7, 128. So then 256. You can just consider. You can just continue the operation. Okay, fine. Now let's try and understand this all things, right? So let me remove this all things. Now the next task that we are going to do now is called, see there, suppose 4 cross 1 mux is not available in the laboratory. இப்போ நீங்கள் வந்து லேபுக்கு போகிறீங்க, லேபில் வந்து என்னென்னா ஜஸ்ட் இப்போ நான் தான் அங்கே இருக்குன்னு வச்சுக்கோங்களேன், நீங்கள் லேபுக்கு வந்திருக்கீங்க, எனக்கு என்ன தேவை அப்படின்னா 4 cross 1 மக்ஸ் தேவை in order to perform the certain task. ஆனால் என்கிட்ட என்ன இருக்குன்னா லேபில் வந்து 2 cross 1 மக்ஸ் தான் இருக்குது. நான் உங்ககிட்ட என்ன சொல்கிறேன் அப்படின்னா, நீங்கள் எதாவது பண்ணுங்கள், பண்ணிவிட்டு 4 cross 1 மக்ஸில் அவுட்புட் வந்து உங்களுக்கு என்ன வந்துச்சோ அதே அவுட்புட்டை வந்து நீங்கள் 2 cross 1 மக்ஸில் எனக்கு கொண்டு வரணும். அவ்வளோதான். நீங்கள் எத்தனை 2 cross மக்ஸ்னால் எடுத்துக்கோங்க. அப்படி ஆப்ரேஷனை முடிச்சதுக்கப்புறம் எங்கிட்ட வந்து சொல்லணும். என்ன சொல்லணும் அப்படின்னா, எத்தனை 2 cross 1 மக்ஸ் நீங்கள் எடுத்துக்கிட்டீங்க in order to design the 4 cross 1 மக்ஸ். நான் கன்ஃபார்மாக ஒரு விஷயம் சொல்லிட்டேன், நீங்கள் 2 cross 1 மக்ஸ் வச்சு உங்களால் 4 cross 1 மக்ஸ் ரியலைஸ் பண்ண முடியும் அப்படிங்கிறத நான் சொல்லிட்டேன், ரைட்? ஸோ யூ கேன் ஜஸ்ட் பர்ஃபார்ம். அப்போ நீங்கள் எடுத்துக்கிட்டு உங்களோட டாஸ்க் என்ன அப்படின்னா, யூ வில் ஹவ் டு கிராஸ் செக், அது பாசிபிளாக இல்லையா அப்படிங்கிறத செக் பண்ணி பார்க்கணும், ரைட்? ஸோ ஃபைன், ஃபர்ஸ்ட் வி ஷுட் திங்க், ரைட்? நமக்கு என்ன தேவை அப்படின்னா, நான் உங்ககிட்ட என்ன டாஸ்க் கொடுத்துருக்கேன் அப்படின்னா, 4 cross 1 மக்ஸோட அவுட்புட்டை 2 cross 1 மக்ஸ் வச்சு நான் ரியலைஸ் பண்ண சொல்லியிருக்கேன். அப்போ நீங்கள் என்ன பண்ணுவீங்க, ஃபர்ஸ்ட் 4 cross 1 மக்ஸுக்கு யூஸ்வலாக நம்ம மைண்ட் எங்கே போகும், 4 cross 1 மக்ஸோட அவுட்புட்ஸ் எப்படி வருது அப்படிங்கிறத ஃபர்ஸ்ட் நம்ம திங்க் பண்ணுவோம், கரெக்டாக? ஆட்டோமேட்டிக்லி அவர் மைண்ட் வில் கோ தேர். ஜஸ்ட் திங்க், ரைட்? யூ நோ நீட் டு மெமரைஸ் எனி திங் ஹியர், அண்டர்ஸ்டாண்ட், ரைட்? ஸோ நீங்கள் இதை தான் திங்க் பண்ணுவீங்க. அப்போ நீங்கள் என்ன பண்ணுவீங்கன்னா, அவுட்புட் என்ன வரும், அந்த அவுட்புட் லாஜிக் எடுத்து எழுதுவீங்க. ஃபர்ஸ்ட் என்ன வந்துருக்குன்னா, S0 பார் S1 பார் இன்ட்டு I0 வரும். செகண்டு S0 பார் S1 இன்ட்டு I1 வரும். ப்ளஸ் தேர்டு S0 S1 பார் இன்ட்டு I2 வரும். கரெக்டாக? 1 what I have done here, 0 0 0 1 1 0, correct. Next we have to consider S0 S1 into I3, correct. ஸோ இந்த அவுட்புட் நீங்கள் எழுதிப்பீங்க. இப்போ இதே அவுட்புட்டை வந்து 2 cross 1 மக்ஸை வச்சு நம்ம ரியலைஸ் பண்ணோம். எப்படி பண்ணுறது? திங்க். எனக்கு மைண்டில் என்ன தோணுது அப்படின்னா, ஐ அண்டர்ஸ்டூட், இங்கே S0 வந்து 2 டைம்ஸ் காம்ப்ளிமெண்ட் ஆயிருக்கு, அதே மாதிரி S0 வந்து 2 டைம்ஸ் வந்து தனியாக வந்திருக்கு, ரைட்? ஸோ ஐ எம் ஜஸ்ட் திங்கிங், இது எப்படி கொண்டு வரலாம் அப்படிங்கிறத நான் யோசிக்கிறேன், ரைட்? ஸோ லெட் அஸ் guys, please join. I think every one of you joining. So let me continue the session. So let's try and design the 2 cross 1 mux, sorry 4 cross 1 mux with the help of 2 cross 1 mux, right? So I'm just considering, see what is our target. So let us take 2 more lines here. I'm just thinking, I too don't know what to do, but I'm just proceeding further. Let me consider 2 lines here with the help of I0 and I1. I'm considering here, and I'm going to consider I2 and I3 here, right? So let's see what happened, and with this let us consider, I2 don't know, please don't draw anything, just think it by yourself, right? I'm thinking in this way, right? So I don't know whether it is correct or not. Let's try and figure out the answer. Let me consider S1 here. Now what happened, if I will provide, if I am putting S naught equal to 0, automatically I naught will come, such that what will happen, S naught bar into I naught will come out, plus if you are putting S equal to 1, then I1 will be selected, because this is 2 cross 1 mux na, its outputs are going to be, when S naught equal to 0, I naught will be selected, when S naught equal to 1, I1 will be selected, such that output will become S naught into I1 plus S naught bar into I naught. Clear? Now coming back to this one, if I am selecting S naught equal to 0, then I2 will be selected, first line. Yes, if I am putting S naught equal to 1, automatically I3 will be selected, such that outputs are going to be S naught, right, bar into I2. What we are going to get, S naught bar into I2, and here plus we are going to get S naught into I3. Clear? Now what we are going to get, so let's continue our journey with this. Now is it okay? Yes, if I will pass these two things here, right, if you ரெண்டு பேரும் இங்க pass பண்ணீங்க அப்படினா automatically what you are going to get in the output side, see, if I am putting once again, if S naught equal to 0, then this line will be selected, if S naught equal to, sorry, if S1 equal to 0, then this line will be selected, then if I will put S1 equal to 0 னு போட்டீங்கன்னா இந்த லைன்ல இருக்க output வெளில வந்துரும், such that it is going to be S naught bar S1 bar into I naught plus, right, automatically this one is going to be S naught S1 bar, we should take complement for S1, S naught க்கு 0, S1 க்கு 0 போட்டீங்கன்னா this line will be selected, right, so your output is going to be S naught, S1 is bar, we should take bar, and with this we have to consider I1 plus, and here we have to, when we are putting S1 equal to 1, automatically this line will be selected, so output will become what, so here we are going to get, so let me consider S naught bar, so what I will put here, I am putting S1, that is S1 equal to 1, right, so what we are going to get, wait a minute, so that is going to be, the line is going to be I2, and here it is going to be what, so here we are going to get S naught S1, S naught S1 into I3. Clear? So that is how we are getting the output, that is, see how we are realizing 4 cross 1 mux with the help of 2 cross 1 mux. So our target is just we have to realize, so the thing is we can do the same operation with the help of 2 cross 1 mux, but see there how many mux that are required for us in order to design the 4 cross 1 mux with the help of 2 cross 1 mux. I took 3 2 cross 1 mux, whereas output is going to be what, 4 cross 1, whichever the output that we are getting, same output we are getting here also, right, so what will be the conclusion here, the final conclusion that I am getting here, it is, right, so if you want to generalize, let me generalize, அப்போ 4 cross 1 mux நீங்க டிசைன் பண்ணனும் அப்படினா, right, so if you want to design 4 cross 1 mux, then I am in need of how many mux should be required here, 2 power n, right, so 2 power n in the sense, for an example here we are considering 2 cross 2 mux na, let me consider 4 cross 1 mux na n equal to 2 yes, if I will put n equal to 2, then I am getting 4, right, but how many mux should be required here, 2 power n minus 1 mux, right, shall we put like this, yes, so such that it is going to be 2 power n minus 1, 2 cross 1 mux should be required in order to design, right, in order to design any, you can select, see there, for 4 cross 1 mux I am in need of 2 power n minus 1, 4 cross n mux la, what is the number of n, that is n is going to be 2, right, so we have to select, such that what will happen, that is 2 power 2 only na, 2 power 2 only will become 4, so n is going to be 2, so 2 power 2 minus 1, suppose if you are designing 8 cross 1 mux with the help of 2 cross 1 mux, so what shall we do, if you want to design 8 cross 1 mux with the help of 2 cross 1 mux, how many 2 cross 1 mux should be required in order to design 8 cross 1 mux, the answer is 2 power n minus 1, right, whereas n is going to be 3, right, so it should be required, there are 7 mux, 7 2 cross 1 mux should be required in order to design 8 cross 1 mux, right, so let's continue our journey with this, I hope things are going good now, so let us rub these things, yeah. See, just to understand, right, so you no need to memorize anything here, and I am not forcing you to do anything, just to understand, the question is how many number of 2 cross 1 mux should be required in order to design 4 cross 1 mux, so we got the answer as, listen, the number of 2 cross 1 mux should be required to design 4 cross 1 mux, actually we got the answer is what, 3, right, we got answer as 3, suppose, right, actually இதை நம்ம வேற மாதிரி எழுதலாம், வேற எப்படி எழுதலாம் அப்படின்னா, so இப்போ ஃபைன் இதை வேற எப்படி எழுதலாம்னா, see, think is யாரை இம்ப்ளிமெண்ட் பண்ண போறீங்க, we are going to implement 4 cross 1 mux, யாரை யூஸ் பண்ண போறோம், 2 cross 1 mux, now here just select, right, so இதோட 2 power என்ன செலக்ட் பண்ணிக்கோங்க, and இதோட 2 power என்ன செலக்ட் பண்ணிக்கோங்க, that is 2 power 2 power 1, இங்க என்ன இருக்கு, 2 power 2 இருக்கு, கரெக்ட்டா, now இங்க என்ன பண்றீங்க அப்படின்னா, the mux that I am going to implement, right? Implemented mux divided by the mux that we are going to use, right? So this is the ratio that you have to use in order to find out the number of mux selection. Number of mux selection, that is very important. I denotes implementation. நீங்க எந்த logic, I mean mux வந்து implement பண்ண போறீங்களோ, that is called I, whereas U denotes use, right? We are going to use the a certain number of that is the selected mux, right? So we are going to use 2 cross 1 mux, right? So யார் இங்க என்ன கன்சிடர் பண்ணோம் அப்படினா இவங்களோட 2 power n ஆர்டர் கன்சிடர் பண்ணோம். If it is இங்க வந்து 4 இருக்கா, yes, இங்க என்ன இருக்கு, 2 இருக்கு. You will have to repeat the operation with this, right? So let us see how to perform this one, right? In order to find out the number of 2 cross 1 mux required to find out the 4 cross, to design the 4 cross 1, select the implementation. We are going to design 4 cross 1 mux by using what? 2 cross 1 mux. Just to divide 4 by 2 such that what we are going to get, see there, if I will divide 4 on the 2 ஆல divide பண்ணீங்க அப்படினா you are getting 2. Again this 2 can be divisible by 2. Again we have to consider, அப்போ 2 ஆல cancel பண்ண முடிஞ்சதுனா திரும்ப அந்த remainder எடுத்துட்டு இங்க போட்டு நீங்க cancel பண்ணனும் such that it is become 2 plus 1. So that is going to be 3 2 cross 1 mux should be required in order to design the 4 cross 1 mux, right? For an example, let us consider 2 cross 1 mux. Question is, how many 2 cross 1 mux required in order to design the 8 cross 1 mux? Anyway, we know the general formula. I said only for 2 cross 1 mux you can use that formula 2 power n minus 1. But for rest of all people, this is the general procedure. The procedure is, first we have to implemented mux divided by using mux. Which mux we are using? Implementation is 8, but we are using what? 2. இப்போ இவங்க ரெண்டு பேரை டிவைட் பண்ணீங்கன்னா see there 2 ஆல நீங்க 4 times இது அடிக்க முடியும் such that 4 into 2 will become 8. Remainder 4 வந்திருக்கா? Actually இது நீங்க எத்தனை டைம் கேன்சல் பண்றீங்களோ அத்தனை டைம் நீங்க கன்சிடர் பண்ணனும், right? It is getting 4 times. Again that 4 also can be divided by 2. எத்தனை டைம்? 2 times. Again that 2 times divide பண்ண முடியும்னா அந்த 2 2 ஆல டிவைட் ஆகும் இல்லையா, such that you are going to get what? It will be 4 plus it will be 2 plus it will be 1, totally 7 mux. Same answer that we got in this formula also. Suppose question is number of 2 cross 1 mux should be required in order to design the 128 1 cross mux. How shall we proceed further? Let me do it. Implemented mux divided by using mux. So that is going to be 128 upon 2 first plus இது எத்தனை டைம் கேன்சல் பண்ண முடியும் உங்களால? இதை கேன்சல் பண்ணா என்ன வேல்யூ வருதோ அதை திரும்ப நீங்க 2 ஆல டிவைட் பண்ணனும். இதை கேன்சல் பண்ணீங்கன்னா 6 times of 2 will be 12, 4 times of 2 will be 8. So 64 வந்திருக்கு. 64 can be divisible by 2. So just to continue the operation. Again if I will cancel this 2, I am getting 3, 2. So 32 also can be divisible by 2. Just to continue the operation. If I will cancel it, I am getting 16. 16 you can divide by 2. So again it will become 8. 8 can also be divided by 2. Again it will become 4. 4 also can be divided by 2. Again it will become 2. 2 also can be divisible by 2. Again I am getting 1. 1 cannot be divided by 2. We don't get the proper integer value such that the answer is going to be 64 plus 32 will become 96. Exactly 96 plus here we are going to get 16. அப்ப என்ன வரும்? 112. So 112 plus 8 will become 120. 120 plus 4 124. 124 plus 3 is going to be 127. 2 cross 1 mux should be required in order to design the 128 cross 1 mux. Clear? I hope things are very clear to you all. Now this is the standard procedure that you can commonly use for all type of combinations, right? For an example, 4 cross 1 mux is given to you and you are requested to identify the number of 16 cross mux 1, right? That is 16 cross 1 வந்து நீங்க implement பண்ணனும். And the question is how many 4 cross 1 mux should be required in order to design that one. So let us continue our journey with that. Yeah. Now the question is using 4 cross 1 mux we have to realize 16 cross 1 mux, right? So the implementation is 16 using 4 cross 1 mux. What shall we do? 16 by 4. Remainder I'm getting 4. 4 can be divisible by 4. Just to continue. So what is the answer? First I am getting 4. Second I am getting 1 such that 4 cross 1 mux should be required in order to implement 16 cross 1 mux. I hope things are very clear to you all. Just to take this one. See, in sometimes நீங்க இந்த மாதிரி டிவைட் பண்ணும்போது if you are unable to divide the logic, right? உங்களால டிவைட் பண்ண முடியல அப்படினா that mux cannot be that such a type of combinations cannot be realizable. For an example, இங்க ஏதோ ஒரு வேரியபிள் கொடுத்திருக்காங்க. Not only in mux, right? In demultiplexer also I am going to repeat the same procedure, right? But the thing is in the logic வச்சு நீங்க perform பண்ணிட்டு இருக்கும்போது suppose if you are unable to divide the logic, sir மேல இருக்க நம்பரை கீழ இருக்க நம்பரால என்னால ப்ராப்பரா டிவைட் பண்ண முடியல, அந்த மாதிரி ஒரு கேसेस வந்து எக்ஸிஸ்ட் ஆகுது அப்படினா you can just skip, right? நீங்க என்ன பண்ணா ஆன்சர் answer is the given mux, right? So the given mux cannot be realizable with the end the mux on that is the implemented mux cannot be realizable with the using mux. That is the answer. The thing is, if this division is not possible, right? Sir, எனக்கு வந்து மேல ஒரு வேரியபிள் கொடுத்திருக்காங்க, கீழ ஒரு வேரியபிள் கொடுத்திருக்காங்க, but I cannot divide them. Divide பண்ண முடியல, ப்ராப்பரான division வரல அப்படினா automatically you can say that mux implementation cannot be realizable. That's all. That is your answer for that one, right? I hope things are clear to you all. So let me rub this one. So that is how we are implementing the mux with the help of, that is any mux can be implemented with the help of any mux, right? And the next thing is one more happiest news is mux can act as a universal gate. Mux is also called universal gate. இது என்ன புதுசா இருக்கு? You might hear these things already in your semester exam itself. இந்த multiplexer இருக்குல்லங்க, it's a beautiful device actually. Entire digital electronic circuits can be implemented only with the help of a multiplexer, right? Do you know this one? That is actually, it is the fact, you have to accept, right? So this multiplexer, with the help of the multiplexer we can design all type of gates, right? So whichever the gates that you want you can bring, right? அப்ப நீங்க என்ன பண்ணலாம், we can perform arithmetic operations, subtraction, என்ன operation வேணாலும் we can perform just with the help of the multiplexer. That's the beauty of your mux, right? Because gates can be implemented with the help of multiplexer, in the sense with the help of gate only entire digital electronics will going to be implemented. If entire digital electronics will going to be implemented by gate, in the sense gate can be implemented by multiplexer, in the sense multiplexer will going to is the only hero will going to play with the entire digital electronic circuits, right? So let's design the logic gates. Mux is also called universal gate because it will going to help us to design all type of logic gates. So your target is designing the logic gates. It's very important. Let's start our journey with that. Now let us see how to design the gates with the help of multiplexer, right? So for that I'm just selecting first, let's go ahead with the 2x1 mux, right? So first thing is you can select 4x1 mux, whichever that is the desirable output. உங்களுக்கு எத்தனை gates select பண்ணா, I mean எத்தனை lines select பண்ணா output வர மாதிரி இருக்கோ, you can just go ahead, proceed, right? So anyway, first let us design the NOT gate. It's very simple, just understand, observe here. NOT gate நம்ம டிசைன் பண்ண போறோம். First of all, we have to know the realization of NOT gate. NOT gate பொறுத்த வரைக்கும் இன்புட்ல நீங்க A பாஸ் பண்ணீங்கன்னா அவுட்புட்ல will become A bar. இது மட்டும் தான் உங்களோட டார்கெட்டா இருக்கணும், கரெக்ட்டா? So let us select multiplexer. Let me try to design this one. Okay. Now we are going up with the 2 lines, right? And let me select one data line for this, yes not. Now actually the output is, inga output enanga varum, very simple. First of all, write the answer. I0 I1 எழுதிட்டு output என்ன வரும், we can write I0 into S0 bar plus I1 into S. This is the output of the multiplexer, we all know. When S0 equal to 0, I0 will be selected. When S0 equal to 1, I1 will be selected. That is the output of the function, right? But our target is, this is not our target. Output la namak enna varanum, I mean it of input la A pass pannina output la A bar varanum, right? So what I have to do, just you have to think, அந்த மாதிரி combination எங்கங்க வந்திருக்க. Listen, what I am going to do, இப்போ நான் என்ன சொல்றேன் அப்படின்னா, இந்த S0 க்கு பதிலா A போடுறேங்கறேன். ஏன்னா இப்போ இந்த 4 பேர்ல காம்ப்ளிமெண்ட் ஆயிருக்க ஒரே ஒரு டேர்ம் வந்து S0 மட்டும் தான். அப்ப நான் இங்க S0 க்கு பதிலா A போட்டேன்னா இந்த டைம்ல இங்க எனக்கு என்ன வந்துரும்னா A bar வந்துரும், இங்க வந்து எனக்கு A வந்துரும். கரெக்ட். ஓகே, பட் ஸ்டில் நவ் ஐ எம் நாட் அச்சீவிங் மை ஆப்ரேஷன். எனக்கு A bar தான் வேணும். அப்ப நான் என்ன சொல்றேன் அப்படின்னா I0 க்கு பதிலா 1 போடுங்கன்னு சொல்றேன். எங்க I0 இருக்கு? I0 க்கு பதிலா 1 போடுங்க. நம்ம தாங்க டிசைன் பண்ண போறோம். நீங்க எதுவும் பயப்பட வேண்டாம். ஜஸ்ட் உங்க மைண்ட்ல என்ன தோணுதோ அப்படியே அப்ளை பண்ணுங்க. இந்த டேர்ம் எனக்கு வரக்கூடாது. ஏன்? A bar தான் என்னோட ஆன்சர். அப்ப இது 0 ஆக்கணும். கரெக்ட்டா? அப்ப I0 க்கு I1 க்கு 0. அவ்வளவுதான். This is the equivalent circuit. அவ்வளவுதான். அது 0 ஆயிடும். So output is going to be A bar. See there, we got NOT gate. Do you all agree with me? Yes. So here it is 1, here it is 0, this is A, such that we are getting NOT gate. Let's continue our operation. Just understand, don't memorize. So let us design OR gate. In order to visualize OR gate, we also know the visualization of OR gate. If I will pass 2 variables through the OR gate, it will perform addition. Your output is going to be what? A plus B, right? So let us see. Yeah. Okay, first we have to write the common expression. I0, okay, let me rub this one. I0 I1, this is going to be S0, right? Such that output of the function is going to be once again S0 bar into I0 plus S0 into I1, correct? Yes, that is correct. Now actually what do we want? I mean of A plus B. என்னங்க பண்றது? We have to do something in order to bring the answer. A plus B நமக்கு வரணும். right? I'm just thinking நான் S0 க்கு பதிலாக ஃபஸ்ட்டு ஏ போட்டுக்கிறேன், ரைட்? அப்போ எனக்கு இங்கே என்ன வரும் அப்படின்னா, this is a bar, this is going to be ஏன்னு வரும், ரைட்? I'm just thinking a plus b வரணும், என் மைண்ட் வந்து something it's playing, ரைட்? நான் என்ன சொல்கிறேன் அப்படின்னா I0 க்கு பதிலாக 1 போட்டுக்கலாங்கிறேன். I0 க்கு பதிலாக 1 வந்துருச்சு. எனக்கு என்ன வரணும், a plus b. அகைன் டிஸ்ட்ரிபியூஷன் தியரம் அப்ளை பண்ணால் ஆன்சர் வந்துடும் என் மைண்ட் சொல்லுது. லெட்ஸ் ட்ரை. யா, இப்போ பாருங்களேன், இது எப்படி எழுதலாம்? அக்கார்டிங் டு டிஸ்ட்ரிபியூஷன் தியரம் இட் கேன் பி ரிட்டன் as a bar plus a into a bar plus a bar plus b வருதா? நமக்கு a plus b தானே வேணும். அப்போ நம்ம ஆப்ரேஷனை ரிவர்ஸ் பண்ணுமா? வாட் ஷால் வி டூ நவ்? வெயிட் a minute, let me try. டிஸ்ட்ரிபியூஷன் தியரம் அப்ளை பண்ணாலும் எனக்கு ஆன்சர் வரல. ஐ திங்க் ஏதாச்சும் மிஸ்டேக் பண்ணியிருப்பேன்னு நினைக்கிறேன். லெட் மீ ட்ரை ஒன்ஸ் அகெயின், ரைட்? I0 I1 S0. I'm just thinking output is what? I'm in of OR gate, right? So S0 into I0, okay, S0 into I1, right? So நமக்கு என்ன தேவை? Just let your brain to work. We need of a plus b, right? a plus b மட்டும்தான் நமக்கு வரணும். அப்போ என்ன பண்ணுறது? Okay, let me try. இப்போ இங்கே a bar போட்டோம்னா again we are going to get a bar plus b only, right? So that is not correct. Suppose if I am putting a here, then automatically what will happen? A plus, if you are putting a, this is going to be a, yeah. Here also if I will put, no, that is not good actually. A plus a is going to be, shall we put S0 equal to 1? Yeah. So let me replace this one. If I am considering 1 here, then what will happen? 1 bar is going to be 0. No, I am not getting the answer actually. Suppose if I am considering 0 here, 0 bar is going to be 1, such that 1 into a I will get here, plus here we are going to get, no, that is going to be 0, na? That is not good actually. We have to select some variable here, I understood. So let me select b. Suppose if it is b, then what will happen? B bar I0 plus this is going to be b into I1, right? Now b0 plus b bar, okay, that is fine. Now what shall we do? For I0 let me put a, let's see. For I1 let me put 1, such that let's see what happened. So b bar I0 I am getting a plus this is going to be b into 1, right? So now what we get? So it can be written as b bar plus b into a plus b. That's all. Just we have to think, that's all, right? Fine. If you have any other combinations, you can just proceed, right? I'm in need of OR gate output. I'm just trying, figure it out. If you have any other logic, where that logic vandana, just you can proceed and you can bring out, right? So that is how we are designing OR gate, right? So let's try the next one. You just try it by yourself, right? So that's why here also I'm not showing any standard way, right? So does not required, just we have to design by ourselves, right? So let me design AND gate. How to design AND gate? We know AND gate, how to design AND gate. So let us consider a and b, output is going to be ab. Just to think, right? Because I too going to think now only, right? So let's see what happened. So we have to consider what? Once again we are going to visualize these things with the help of mux, right? So we need what? AB. Of course, first of all, our target is we have to write the general expression I0 I1 S0, such that output of the function is going to be S0 bar into I0 plus S0 into I1. Now our target is in the output side, I'm in need of AB, right? So I'm just doing S0 க்கு பதிலா நான் A போட்டுக்கிறேன், such that it is become A bar, it is become A. Immediately my mind is thinking I'm in need of A dot B only. Very simply I1 க்கு பதிலா B போட்டிங்கன்னா automatically it will become B. I don't want this term, so just let me make I0 equal to 0, such that it is 0, we are going to get AB. Yes, we got AND gate exactly, right? So let us design the next gate. Now we have to design NOR gate. Let us design NAND and NOR, whichever the gate that you want, you can design first. Let's proceed NOR gate and then proceed with the NOR, and then we will design NAND gate. NOR gate in the sense we know how to do, that is the inverted version of OR gate, such that if I'll pass AB through it, it will become what? A plus B whole bar, or according to De Morgan's law, it can be written as A bar dot B bar, such that, so let us realize it through mux. Let us realize this one through mux. So what I have to do, once again we have to consider the people, that is S0, and output is going to be what? This is going to be I0, this is going to be I1, such that output is going to be what? S0 bar into I0 plus S0 into I1, such that, see, what do we want now? I'm in need of A bar dot B bar. Actually, we have to achieve A bar dot B bar. So what shall we do? So let me replace S0 by A, such that what I'm going to get, we are going to get A bar into I0 plus A into I1. So very simple, just replace I0 by B bar, because one more complementation could not be directly possible here. If you observe these things carefully, இப்போ நீங்கள் என்ன பண்ணணும், இந்த இடத்துல இன்வெர்டர் டேரெக்டாக இன்னொரு மக்ஸ் எடுத்துகிட்டு வந்து இங்கே அட்டாச் பண்ணணும். We know how to design the inverter with the help of mux. One more mux should be required in order to attach here, because here two terms are going to be complemented, right? So in order to take complement for two people, see there, directly in mux only one person is being complemented. In order to consider one more complementation, I am just considering one more mux gate here, such that I0 is going to be B bar. What about I1? I don't want that one, just to make it 0, because this is not the desired output, this is what I want, right? So that is going to be the NOR gate implementation, right? So let's see the next one, NAND gate, right? So let's realize NAND gate also. Let me rub this one. It's very simple, right? That's what I'm telling. Realization of NAND gate. Let's see what happened. So this is going to be A, this is going to be B, such that output is going to be A dot B whole bar, or you can say A bar plus B bar. That is the output of the function, of course. So let's realize with the help of mux. Yeah. Now what I am going to do, let's consider S0. This is A, this is going to be B, and our output is going to be what? S0 bar into A plus S0 into B. Right? Now what will be the output? The output is going to be okay, direct number answer pottomo. Guys, listen. Sorry, let's I have to let you to think. I don't know why I am putting unknowingly, sorry, unconsciousness. Fine, let's proceed. We should think A bar plus B bar should be required. For that, what shall we do? Okay, one complement could be created with the help of S0, such that it will become A bar, and this will become A. Fine. What about the other logics? I made of A bar plus B bar. Appo enna varano? A bar is available here. Appo I0 க்கு பதிலா 1 போட்டுக்கலாமா? Such that it will become 1. B bar வேணுமே. So what shall we do? Very simple. I1 க்கு பதிலா direct if I am attaching B bar, then what will happen? According to distribution theorem, once again you will get the result as A bar plus A into A bar plus B bar. Correct? Exactly, that is correct. So such that this term is going to be 1, we all know. So your answer is what? A bar plus B bar. That is what we are getting for NAND gate, right? I hope things are clear to you all. Now we have to design the next gate, right? So NAND gate is over. I am giving small task to you all, right? So there are two more gate is pending, right? Which are them? One is XOR gate, special gates. Another one is XNOR gate. We have to visualize XOR and XNOR gates, right? Okay, let me visualize one thing by myself. XOR gate, right? So XOR gate can now room. Very simple, right? Very simple. I'm repeating once again. Don't memorize anything, right? Just understand and proceed further. What is the output first? First of all, I0, this is going to be I1, such that output is going to be I0 into S0 bar plus I1 into S1. You can also interchange, right? Such that what happens? First of all, we can bring one complement. A க்கு நீங்க இது S க்கு போட்டீங்க அப்படினா automatically it will become A bar. Here it is become A. Now what is the output of XOR gate? That is A bar B plus A B bar. We all know A bar B plus A B bar. Now what I got already, A bar is ready now. With this what? B வரணும். So I0 க்கு பதிலா B போட்டுக்கலாமா? Yes, this is become B automatically. Already A is available. I mean of B bar. அப்ப இங்க என்ன போடுவீங்க? Over, operation is over. Or you can simply say I am just putting one inverter here and I am just connecting here. So the output is going to be what? This is our XOR gate. Similarly, you can also visualize. Okay, let me do it by myself. I don't want to let you in trouble. A bar B bar plus AB. This is our XNOR gate. Let's visualize this one also. That is A, B. This is output. This is selector line S0, such that output is going to be what? Okay, listen, see. Actually, my mind is doing some other operation. Please forgive me. I'm blowing, right? My mind is doing some other things in my mind. I just should control. Okay, fine. Let's start our journey. Output is what? S0 bar into I0 plus S0 into I1. So operation is what? S0 bar. Automatically, I mean of what? A bar, B bar plus AB. First of all, just by replacing S0 by A, we can consider A bar I0 plus A into I1. Second task, A bar into B bar or no. I0 க்கு let's consider B bar. I1, let's consider B. Operation is over. B bar, this is going to be B. Did I make any mistake? That is how we are realizing. See there, almost we had realized all logic gates just with the help of multiplexer, right? I hope things are very clear to you all, right? So just to make very clear notes, this is all about multiplexer, clear? So next we have to design demultiplexer. Just we have to reverse the process. In order to design the demultiplexer, what we need to do, just we have to reverse the process, we have to go ahead. நம்ம என்ன சொன்னோம், அதாவது மல்டிப்ளெக்சர் அப்படிங்கிறது டேட்டா செலக்டர். இதே டிமல்டிப்ளெக்சர் அப்படின்னா டேட்டாவை டிஸ்ட்ரிபியூட் பண்ணுறாரு. நீங்கள் செலக்ட் பண்ண டேட்டாவை எல்லாருக்கும் டிஸ்ட்ரிபியூட் பண்ணோம் இல்லையா? தட்ஸ் வெரி இம்பார்ட்டன்ட், ரைட்? நான் இங்கே பேசிட்டேன், அந்த சிக்னல் உங்கள் எல்லாருக்கும் ரிசீவ் ஆகணும்ல. ஹவு மெனி பீப்புள் ஆர் வாட்சிங் அட் தி சேம் டைம்? ஸோ எவ்ரி ஒன் ஆஃப் யூ ஹேஸ் டு ரிசீவ் தி சிக்னல். தட் இஸ் தி ஒர்க் ஆஃப் டிமல்டிப்ளெக்சர், ரைட்? இட்ஸ் டார்கெட் இஸ் இட் ஹேஸ் டு டிஸ்ட்ரிபியூட் தி டேட்டா, ரைட்? ஸோ லெட்ஸ் டிஸ்ட்ரிபியூட் தி டேட்டா இன் அவர் நெக்ஸ்ட் கிளாஸ், ரைட்? ஸோ வித் திஸ் லெட்ஸ் வைண்ட் அப். இஃப் யூ ஹேவ் எனி டவுட்ஸ் யூ கேன் ஆஸ்க் இன் தி குரூப், ரைட்? ஸோ லெட்ஸ் வைண்ட் அப். தேங்க் யூ ஆல்.